Now this is the third part of how to solve Newton's Newtonian problem in Newtonian mechanics. The first one was to identify constraints. The second was make free body diagrams. And this is the third one, which is write Newton's equation. Well, so let's talk about the same problem. We have this mass, let's say m2, this is mass m1, and we want to write Newton's equation for both the masses. First of all, referring back to the last lecture, the free body diagram looks like this. Similarly, for the other one, the free body diagram will be, well, that's alright, tension and m2g. Now Newton's equation are F equals ma, which are also written as Fx equals max and Fy equals may, and these are for each body. So let's write Newton's equations for these bodies. But first of all, let's define an axis system. So for this body, let's say this is the x-axis and this is the y-axis, and for this guy, let's say this is the x-axis and that is the y-axis, right? Okay, now as we said that all we are doing here is sort of separating a vector problem into two axis systems, which is x and y, so we can write Newton's equation in two separate problems. Well, as a matter of fact, it actually means sum of all the fx's. This is the right term, that you add all the fx's and that should be equal to max. So let's try this body first. Well, it looks like this guy has nothing to do with the x-axis. All it has to do is with the y-axis. So let's see what is sum of Fy for this guy. Now for this guy, you see tension is in the positive y direction while m2g is in the negative y direction. So sum of Fy's will be T minus m2g, and this should be equal to, now it says ax and ay, and you can see this is ay and this guy is moving forward with ax, right? Ax means acceleration associated with the x-axis and ay means acceleration associated with the y-axis. We already have figured out that ax is equal to ay in the earlier class because the length of the string is constant, and let's collectively call it a. So if you write this, this is the net Fy. Moreover, you see ay or a is actually pointing downward because we already have assumed that the whole system is moving like this. So if ay is pointing downward, which means it's a negative acceleration because y has been defined upwards. So this is going to be m2 minus a, where a is some number. Okay, there's nothing in the x-axis. Let's talk about this particular mass, the other mass. So this was 2, mass 2, and let's talk about mass 1. For mass 1, we see that there is motion along the x-axis, and sum of Fx is, well, you see tension is pointing along the positive x direction, and that is the only force which is present, and this should be equal to max. Well, ax is a, so it's m1a. How about in the y direction? In the y direction, the net force is n, because n is pointing along the positive y direction, minus m1g equals ma. And now m1a, but there is no ay in the, for this particular mass. This guy is not really moving up or down, so net a in the y direction is 0. So this whole thing actually is 0, which is not going to play any role in solving the equation. Okay, so that is the third step. We have written down the equation of motion, and the fourth step to solving problems in mechanics is solve the equations. So we have, you see, one equation here and one equation here, and we need to solve it. How will we solve it? Well, you see, there are two equations and there are two unknowns. T is not known and A is not known, and also there are two equations. So in principle we can solve it. How? Let's replace m1a for t in the first equation. So m1a minus m2g equals minus m2a, and that gives us a equals m2g divided by m1 plus m2, right? So this is the answer, that this guy is moving down with an acceleration a, and this guy is moving forward with an acceleration a. In the next lecture we'll take a little more difficult problem so that things become more clear.